Hello and welcome to this video presentation on the basics of residual circuit devices or RCDs. My name is Martin Lavačka and in this video I will talk about the function of RCDs, their types and their forms. Before moving on to the next slide, I recommend that you watch a video on electrocution protection that I made so that you understand all the information mentioned in this video in context. I'll leave a link to the video in the description. Now let's get started. To prevent current from passing through the human body, if it is due to direct contact with a live part or insulation failure due to damaged circuit or faulty device, a device is needed that automatically disconnects the power supply from the circuit. Before continuing, let us briefly summarize the function of circuit breakers to avoid confusion or misunderstanding. Circuit breakers protect conductors against overload currents and short circuit currents. They are not able to detect a low residual current. In other words, circuit breakers do not protect you from electrocution. To protect people from electrocution, another solution is needed. Let's do a quick summary of the three principles to protect people from electrocution. The first principle is to insulate live parts according to standards, replace damaged cables, and install barriers or enclosures. The second principle is to implement an earthing system to keep faulty devices at earth potential. The third principle, which we focus on in this video, is to install RCDs or highly sensitive residual circuit devices. RCDs protect people against electrocution through direct or indirect contact. How? RCDs detect residual current to earth, which may or may not come from a human or animal. In the event of residual current detection, the device automatically disconnects the power supply quickly enough to prevent injury or death from electrocution. High sensitivity RCDs are suitable for all types of earthing systems, TT, TN, and IT systems. Let's play the first video showing how RCDs protect people against direct contact. Now let's play the second video showing how RCDs protect people against indirect contact. Good. When does the RCD trip? Currents greater than 40 mA are dangerous for the human body, so the standard recommends a sensitivity level of 30 milliamperes for RCDs. 30 milliamp RCDs are required in many situations depending on local regulations. According to IEC 60364-4-41, 30 milliamperes RCDs must be provided for circuits supplying general purpose sockets with a rated current less or equal to 32 amperes, for circuits supplying mobile equipment with a rated current less or equal to 32 amperes, for outdoor use, and final AC circuits that supply luminaries in the home. It is also recommended to limit the number of sockets protected by an RCD, for example, 10 sockets per RCD. Now, how to select the correct type of RCD? There are different types of RCD. To ensure the protection of people against electrocution, the type of RCD must be tailored to the application and the related type of fault current they can cause. The correct type of RCD will ensure not only adequate protection of people from earth leakage, but also continuity of service by avoiding nuisance tripping. Selection of the correct type of RCD depends on the type of load and network disturbances. There are 6 different types of RCD. Let's look at these types of RCDs one by one. The first type of RCD and the most common type is the IC type. Type AC is defined by IEC standards 60755, 610081, 61009-1. It is suitable for general use and covers most applications in practice. This type of RCD senses and trips with default values of 50 Hz pure sine wave. AC type RCDs protect people by tripping in the event of an earth leak with linear loads such as lighting, ovens, water heaters, or class 2 loads such as vacuum cleaners, alarm clocks, laptops, etc. The second type of RCD is type A. Type A, this type of RCD senses and trips with default values of 50 Hz pure sine wave, as well as pulsating DC waveform. Type A RCDs protect people by tripping in the event of an earth leak with the same loads as type AC, plus with class 1 loads like computers, screens, embedded loads with rectifiers like single-phase photovoltaic inverters, and voltage transformers like induction cooking plate, for example. The third type of RCD is type A superimmunized, designed by Schneider Electric. This type of RCD is used where service continuity is a major concern to avoid nuisance tripping due to the electromagnetic disturbances on the network, such as high-frequency harmonics or surges. Superimmunized type RCDs protect people by tripping in the event of an earth leak with the same loads as type A, and also support network disturbances. Type A superimmunized RCD is recommended for the continuity of service of critical loads such as IT rooms, cold rooms, freezers, swimming pool pumps, and office air conditioners. The fourth type is type F. This type of RCD senses and trips with 50 Hz pure sine wave defaults, pulsating DC waveform, and mixed frequency defaults. Type F RCDs protect people by tripping in the event of an earthly with same loads as Type A, plus single phase loads with variable speed drive, frequency converters, heat pump, air conditioning, and single phase lift pump. Type A superimmunized RCD is capable of offering the same level of protection as Type F, plus continuity of service for critical loads. The fifth type is Type B. This type of RCD detects and trips on 50 Hz pure sine wave defaults, pulsating DC waveform, mixed and high frequency defaults up to 1000 Hz, and smooth DC defaults. Type B RCDs protect people by tripping in the event of an early with the same loads as the Type F, plus three-phase motor with variable speed drive such as the elevator, and devices that incorporate an AC-DC converter such as the EV charger. The sixth type of RCD is Type B superimmunized, designed by Schneider Electric. This type of RCD is used where service continuity is a major concern to avoid noisy and stripping due to electromagnetic disturbances on the network such as high frequency harmonics or surges. Superimmunized Type B RCDs protect people by tripping in the event of an early leak with the same loads as Type B, and also support network disturbances. Type B superimmunized RCD is recommended for the continuity of service of critical loads such as medical facilities, elevators, and three-phase HVAC systems. Each type of RCD is easy to identify as it is written on the product with a specific logo related to the level of protection. As you can see in the image, the Type B and Type F logos can also have an all-in-one representation. RCDs are easy to recognize thanks to their test button. It does not require continuous monitoring during operation, but periodic checking of the RCDs may be required. RCD testing should be performed every 3 months and documented to maintain compliance. After pressing the test button, the device trips and the circuit supply is disconnected. Otherwise, the device will need to be replaced. Different forms of RCD can be incorporated into the electrical installation. The first form of RCD is residual current circuit breakers, or RCCB, which is the most common. The second form of RCD is a residual current circuit breaker with overcurrent protection, or RCBO, which is a two-in-one product. It protects against earth leakage and overcurrent. The third form of RCD is the VG add-on, designed by Schneider Electric, a module that combines with an existing circuit breaker to also provide earth leakage protection. The fourth form of RCD is the earth leakage circuit breaker, or ELCB, which is a two-in-one product. It protects against earth leakage and overcurrent. The main difference with an RCBO is the higher sensitivity and rating settings capabilities. And the fifth form of RCD is a relay with separate toroidal current transformers that cause disconnection of the power supply to the circuit automatically through a circuit breaker. We have reached the end of this presentation. Now you know the basis of RCDs. Thank you so much for watching. Stay tuned for the next video where I will talk about how to promote continuity of service through selectivity.